and the chlorine ion. Same thing here, the hydrogen sits there, you get the hydronium ion and the nitrate ion. Now, the same thing here with sulfuric acid. The hydrogen goes and it sits there, but now you have two hydrogens, okay? But you do not get something like H4O2 plus. That does not exist, okay? It still forms hydronium ion, and I'm going to explain what else will form in a moment, and the sulfate polyatomic ion. But it's giving away two hydrogens and must go somewhere. Okay, now, Khali, let's start with you. What do we call, or what is the prefix 1 called in the science class? And 2? And 3? So 2? Di. 4? 4 is tetra. Tetra. Have you ever heard of Tetris? It has 4 blocks rearranged in different ways. Okay, so good. 2 refers to di. So this thing there can give away 2 hydrogens. So this is called an diprotic acid. A diprotic acid. Di referring to 2. Protic, protons. Okay. We said here that the hydrogen ion represents a hydrogen ion or a proton. Why does hydrogen ion represent a proton? Because if you look at hydrogen, it actually consists of 1 proton and 1 electron. That's all it has. So if it loses an electron, if it becomes a hydrogen ion, then it has 1 proton still and 0 electrons. So if you have a hydrogen ion, it is just a proton. That's all it is, a 1 single proton floating around. So when we say it's a diprotic acid, we say it has 2 protons that it can give off. Okay, so these are called monoprotic acids because it gives away 1, and these are called diprotic acids. But I have written it down, I think on page 6. No, it will come there on page 7. So we will get to it. Okay, but now we must balance it. If it gives away 2 hydrogens, so it can give away 2 hydrogen ions, then that will need to react with 2 water molecules to give you 2 hydronium ions. Okay? So because it gives away 2 hydrogens, it will need 2 water molecules to produce 2 hydronium ions. Okay? And it will always be like that. If it is a diprotic acid, there will be 2, 2. If it is a triprotic acid, like this one, it will need 3 water molecules to give you 3 hydronium ions. So 3, 3, 3, always. Okay, then we go over to the bases. We have lithium hydroxide ion and hydroxide ion, sodium ion and hydroxide ion, potassium ion and hydroxide ion. Dissociation means in the presence of water, and ionization means with water. Okay, right, now we're going to go to reactions. But before we can get to that, 2 more definitions. Okay? As scientists, as human beings, we like to classify things. Boys, girls, high, low, up, down, strong, weak, right? Big, small. So we like to classify things. Now, they wanted to classify the difference between acids and bases, and a guy named Arrhenius came up with these definitions for acids and bases. He said, an acid is a substance that produces hydrogen ions in water. Rory sang, put away your cell phone. And a base is a substance that produces hydroxide ions in water. Okay, so he said that is the definition of an acid and a base. Okay, let's apply it. And sorry, he says in water, in water. So if we look, what he thought happened is sorry, my pen fell. the nitric acid molecule in the presence of water. He thought that happened. Splits up into the hydrogen ion and the nitrate ion. Okay, so according to his definition, acid produces hydrogen ion. Sharp. If we look at the base, sodium hydroxide, he thought in the presence of water, it gives you the sodium ion and hydroxide ion. A base produces an hydroxide ion. Sharp. But then, when you get calcium hydroxide, it gets a bit funny because calcium oxide, when that split up, it gives you calcium ion and an oxide or an oxygen ion. So if you look there, he said a base produces hydroxide ions. A base did not produce hydroxide ions. So his definition is not 100% foolproof. His definition, yes, it does fit some scenarios, but not all. So that is why it is called the old Arrhenius definition. Okay, because it doesn't apply in all scenarios. So then two people came up with a more adequate definition, and they are called Lowry-Broinstedt. Lowry-Broinstedt. Say again? Two people. Something Lowry, something Broinstedt. Broinstedt. Okay, so Lowry-Broinstedt, the theory for acid and a base is the following. It says an acid is a proton donor meaning giving away. And we've discussed now what is a proton. It's just a hydrogen ion. And a base is a proton acceptor. Acid gives away, a base takes. Okay, let's see how that will work. Sorry, something nice. Okay, so we have hydrochloric acid reacts with ammonia. Okay, sorry, and this is a reversible reaction. Yes. We are giving and taking away protons. We're not busy with electrons. Okay, so hydrochloric acid and ammonia is ammonia. Where do you find ammonia? In cleaning agents, soapy things. So it's a base. Okay, so what will happen here is this hydrogen will go sit on the ammonia so that you get the ammonium ion. And Flonnie, what special type of bond? I know we're not somewhere there, but you left this out in the exam, that's why I'm picking on you. What special type of bond do you find in the ammonium ion? This is the third time I'm asking it this week. You're going cold Sepo. Dative covalent bond. Mooi. So, right, so you have ammonium ion and you have the chlorine ion. Okay, so let's check. This is an acid. How do you know it's an acid? You studied it. Its name is hydrochloric acid. What happened to it? It gave away the hydrogen. It donated a proton. What happened to this base? It accepted. It took in a proton. Are you with me? Okay, so it says there, we have a proton transfer from the acid to the base, and that is called a proteolytic reaction or protolysis. Protolysis or proteolytic reaction, where there is a transfer of a proton, a transfer of a hydrogen ion. Okay. Now, they say there an equilibrium is reached. Equilibrium can only be reached if you have a reversible reaction. if you have a reversible reaction. Okay, you don't get those a scale that's like. Let me Google that for you. Huh? I'm gonna show you now. Scale, balance scale. Ah, bit pompies. Okay, you know these scales? Okay, this is called the balance scale. Now, for it to be 100% in equilibrium, it needs to be weighed equal. But it can still balance if it looks like this, right? It doesn't fall over. Okay, so you can still get an equilibrium. You can still find a rest point that both are satisfied with if it is like this. Are you with me? Okay, so they say that we reach equilibrium, but equilibrium does not have to be equal. Equilibrium just means it will find its rest point, its end point, somewhere where both are. Okay, so it says there that an equilibrium will be found, is reached through the relative strength of the acid and the base. Meaning, if you have a very strong acid, it will produce a lot of product. It will be like this, but it will still be at equilibrium. Okay, or if it's weak, then it will be like this. Are you with me? Okay, right. Now, when you have that, or when can you have that? Only if you have a reversible reaction. It goes back and forth and back and forth and back and forth with that. And when we have an acid that reacts with a base, we form acid-base conjugate pairs. Conjugate acid-base pairs. So it has just a very fancy name. Conjugate acid-base pairs. Okay, so what you're going to do, because you're going to have to pair them up and give me the pairs and in a test structure. So what you do is you pair up the things that looks similar. This one, does it look like this one? No. Does it look like this one? Does this look like this? No. Does this look like this? Yes. So you're going to pair them up. These two will form an acid-base pair. And they look similar. Not the same, similar. No, I can say, who looks similar in this class? Yeah, no one. But the Carabello and Carabo in grade 10, the Tuche, the twins, are they the same, exactly the same? No, but they're similar. They look more or less the same, but they're not the same. Same thing, okay? And these two are similar. Okay, so you pair them up. Now we have to say which one is an acid, which one is a base. Okay. Now, where are we with the questions? See, you've been waiting this whole period. You are anxious. Tell me, this one, is it an acid or a base? How do you know that?
Because we had to
Say again?
Because we had to learn that.
You had to learn it. Its name is hydrochloric acid. Ma'am, it's an acid. But you can also, if for whatever reason you have no idea in a test or exam, you can, by the help of this definition, figure out what it is. They say an acid is a proton donor. It gives away a proton. This thing from here to here, what happened? It gave away that thing. So that is why this thing is an acid. Okay, so this is an acid. Okay, so what is this thing then? Is it an acid or a base? Okay, this is a reversible reaction. So it means you can go forward or you can go backwards. So let's consider backwards. You had the chloride ion. Backwards, it formed that. What happened to go from there to there? What needed to happen? It needed to gain something, accept something. So it accepted a proton, so it is a base. So this thing is called the conjugate base. So the thing on the other side of the bracket is the conjugate what? No. Okay, so it will always be like that. If this thing is the acid, then its friend is the conjugate base. Always. You can't have acid and acid. Okay, let's see what is this thing. I've already said, but let's look at the definition. What happened from here to here? It gained a hydrogen. So it accepted a hydrogen. So this is the base. So then its friend is the conjugate acid. I wonder if this word conjugate is in the dictionary. For example, you're going to look it up for us. See if we find it in the dictionary. Okay. And then sometimes, we get substances that can do both. It can give away a hydrogen and take a hydrogen. And then we call them, something that can donate and receive a hydrogen, are called amphoprotic or ampholites. Now that sounds familiar. Yes? Something. Who takes life sciences? Only Ona. Okay. Really? It sounds like something that you've heard about in life sciences. Amphibia, what's that? Dat jy moet luister. What is special about a frog? Land and water animals. Now, amphibian can be on land and in water. Now, same with an amphoprotic. Protic, proton. So it can donate proton and accept a proton. Okay. Have you found the word, Rory?
I found it and I lost it. But it says something about give something.
Did you read? Or do you have a question?
Is a crocodile also amphibious?
I'm not a life science teacher. I have no idea. I'll say yes. But then again, they must come up to breathe, or can they breathe underwater? Do they have gills? No, then I will say no. They what? Oh my word. Imagine that. Okay, right, so let's look at these reactions. Yes? Okay, loud and clear. Everyone must hear.
Give the inflections of a verb, it gives the inflections, and the other one says complete set of inflections.
Inflection. What is the word inflection? Alright, so while she's looking that up, so we are now going to write acid-base reactions, and then we're going to pair them up, say which one is acid, which one is a base. Okay, here we have hydrochloric acid, reacts with water. It's a reversible reaction. Did you answered something there, Hope? Did you? No, Hope? What will form? When I say acid, you say? No! When I say Einstein, you say science. When I say acid, you say? No! Anyone? Hydronium ion. It does. I don't care. It's for all of you. It's not person that must remember it? Sure. Okay, so what will form is this hydrogen will go to the water and it will form the hydronium ion. And what else? Hope, because you didn't answer correctly. Say again. I heard something and it sounded correct, but I just couldn't hear clearly. Say again. Just this. What? So chloride ion. Yes.
Why do they form an ion? Like,
Because it gains something that has now more like. This is a proton, right? So it gives to this thing now it has more protons than electrons, and this one has now one more electrons. Okay, Cloney, please pair them up for your inflections.
it's change in the pitch of the voice.
Or okay, so I think we can go with change. So and then what was the previous definition? The inflection of.
Give change.
So it's the
Give inflections or gives change.
so it gives change. It does not make sense at all. We will Google it, and by we I mean I. When I'm bored, while I'm awake in the middle of the night with the baby. Okay, right. Pair them up, Cloney. Go. It's nie, Rory. Not nothing makes sense. Cloney, what looks the same there? Not the same as, similar to.
Similar to. Then H2O. Similar to
Hydroxide. Hydronium ion. I say acid, you say? Okay, thank you very much. Right, now we need to say which one is an acid, which one is a base. Courtney? Courtney?
We have hydrogen chloride is
Yes.
and then
Why is it an acid?
because it's in the name
And?
and because it gave away its proton.
Yes.
And then the chloride on the other side is going to be our base.
Our conjugate.
And then our water is going to use where so it's going to be our base.
It accepts, so it's our base, yes.
It's our base, and then the hydronium ion is going to be our conjugate acid.
Because it's always an acid. Yeah?
Isn't water like neutral?
Good question. We're going to get to that, hopefully. Okay, so, few things. If this is an acid, then the thing on the left-hand side, next to it, must always be a base. You can't have this side an acid and an acid in the base and the base. Okay, so if this is an acid, then this will be a base. If this is an acid, then its friend must be a base. So if you can figure out one of the things, you can figure out the rest. Okay, I'm going to get to water. You see here, water, you frown a bit. Let's go on. Okay, so here we have ammonia that reacts with water. What will form a relay? No, because if that thing gives away a hydrogen to that to form a hydronium ion, what do you have left? NH2. Have you ever seen NH2 in your life? No. So, Call a friend, ask the audience. Cloney. Mr. Clever. Huh? So, water will give a hydrogen to ammonia and it will form the ammonium ion. Ronnie, with what type of special bond? A dative covalent bond. And what is left, Niakalo? No. Water gave away our hydrogen. There. What is left? No, that is what forms. What is left? Yes. Courtney. The hydroxide ion. Okay. Now let's pair them up. What looks similar, Sebabaso? Yeah. And what else? Yes. Okay. Ona. Alright. We will complete in the next class.